Hi everyone, welcome to today's GCSE revision video. There's 4 days to go to your GCSE maths exam, and today we're going to do a recap of the statistics or the probability or data handling topics. So we're going to do a recap of those topics today. It might be quite useful to have pen and paper ready to write down some of the key information to remind yourself, or just sit back, relax and enjoy it. So let's get started. Hi, welcome to this GCSE Higher Statistics recap. So in today's video, we're going to go through the statistics topics, and I'm going to do a quick recap on each of them. If you want a more detailed explanation of each of the topics, if you go to Corbettmaths.com and go to the ultimate GCSE Higher revision video, between 8 hours, 40 minutes and 51 seconds and 10 hours, 12 minutes and 43 seconds, I cover all these topics in a lot more detail. Alternatively, underneath the Corbettmaths logo on every single slide, you can see the video number on Corbettmaths. So if you want a bit more help or some practice questions, that's where you can go. Okay, so in this video, we're going to go through the orange topics from the GCSE Higher Revision Checklist. So these are the statistics topics in orange. You got frequency trees, two-way tables, pie charts, scatter graphs, histograms, cumulative frequency, box plots, quartiles, estimated mean, stem and leaf, frequency polygons, combined mean, median from frequency tables, the modal class from frequency tables, probability, relative frequency, samples, true diagrams, conditional probability, and Venn diagrams. Okay, so the topics we're going to go through in this video is a quick recap. Okay, so let's get started. Frequency trees. So here we've got frequency tree. It's important that you know how to complete them. So it might be that you've got some information in the frequency tree like this one, and you might need to fill in this number. And if there's 40 people altogether and 23 had morning appointments, the rest, the other 17, must have evening appointments. In terms of this one, if there's 23 in the morning and 21 are on time, the other 2 would be there. So these two numbers need to add together to be that number, and so on. And here, if this is 5, there must be 12 there, because 12 plus 5 is equal to 17. So you might be asked to complete a frequency tree, and that's quite important. Also, you might be given questions where you've got to write down, for instance, what fraction of the morning appointments were late. So then that'd be 2/23 and so on. So make sure you're able to answer questions involving fractions and so on whenever you're dealing with frequency trees. Okay, next topic, two-way tables. So sometimes you might be given a two-way table and you've got to fill in some missing numbers. So for instance, here the art students. So in total there's 19 art students, and if 12 failed, that must mean that 7 passed. These two numbers must add together to be 19. Here, in terms of the students that failed, altogether 13 failed. So that means that 1 English student failed, because these two numbers need to add together to be 13, and so on. And then you do 25 plus 7 is equal to 32. Then you'd add these together to be 45. You could add these together to be 26, and so on. So completing two-way tables hopefully is quite straightforward, but also sometimes you might be given wordy questions. So make sure you know how to create your own two-way table and complete those as well. It's important you know how to draw pie charts and read pie charts. So in terms of drawing pie charts, if you were given a frequency table like this, make sure you know how to find the angles for each one of the sectors. So here, if I wanted to find the angle for England, France, Ireland, Scotland and Wales, those angles, I would add up the frequency and find the grand total. In this case it's 90. Then I would take 360 and I would divide it by the total frequency. So 360 divided by 90 is equal to 4. So each person is represented by 4 degrees, and then I would just multiply each of them by 4 in this case. So times by 4, times by 4, times by 4, and times by 4, and that would tell me the angles. And so here that would be 20 times 4 is equal to 80 degrees, 5 times 4 is equal to 20 degrees, and so on. And then you can get each of the angles. And if you want to, you can add up the angles at the end and check that they add up to be 360 degrees. And that's how you get the angles for drawing a pie chart. Now in terms of drawing a pie chart, you'll often have the circle and that line drawn for you. And if that line's not drawn for you, make sure you draw a line going straight up to the top, and then just get your protractor and then measure each of the angles. So you'd start off, you'd measure the first angle, which was 80 degrees. You go around to 80 degrees, put a dot, draw a line through it, and that'll be the first sector. Then you rotate your protractor, so then it's on that new line, and so on. And then you just draw that pie chart. And make sure whenever you're drawing your pie chart, you label each of the sectors. So you'd label one of them England, one of them France, one of them Ireland, one of them Scotland, and one of them Wales. Okay, so that's drawing pie charts. In terms of reading pie charts, so here we've got 2 pie charts. We've got one for under 13s and one for under 15s. Now these are quite useful in telling us some information about the proportion of matches won and the proportion of matches lost. So in terms of the under 13s, they won a quarter of the matches and they lost 3/4 of their matches. And if you knew how many they played in total, you could work out how many they won and how many they lost. Likewise with the under 15s, in terms of this sector, it's 120 degrees. If you do 120 over 360 and cancel that down, cancels down to be a third. So that means that they won a third of their matches, and then that means they lost 2/3 of their matches. And again, if you knew how many matches they played, you could then work out how many they won and how many they lost. And one thing to note whenever you've got pie charts, if you've got 2 pie charts like this and you were asked, did the under 15s win more matches than the under 13s? Remember that the pie chart only shows the information in terms of what the proportion of matches that the under 15s won and the proportion of matches that they lost. So they won a third and they lost 2/3, but without knowing how many they played, you wouldn't actually know those actual figures. So in terms of, if you ask questions in terms of, did the under 15s win more matches than the under 13s, if you know how many matches they played, you could work that out. But if you don't know how many matches they played, you can only say they've won a larger fraction or proportion of their matches. Okay, our next topic is scatter graphs. So make sure you can plot points on scatter graphs and draw lines of best fit if you're asked to as well. And also make sure you know how to use a line of best fit. So if we were asked to estimate the value of a car that's 3 years old, we would go to 3 years old, we'd get a ruler and pencil, draw up to the line of best fit and across, and that's equal to £6,000. So make sure you can plot the points on scatter graphs, make sure you can draw the lines of best fit, make sure you can use your lines of best fit to read off values and make estimates. Also make sure you know when it's not really advisable to use your line of best fit to make estimates. So for instance, if I was asked to use my line of best fit to estimate the value of a car that's 20 years old, because that's beyond the range of the given data, then that wouldn't be sensible. So it's important you can plot points on scatter graphs, draw lines of best fit, also use your line of best fit and say when it's sensible to use your line of best fit. Also, you might need to talk about the types of correlation, so make sure you remember your positive correlation, your negative correlation, and what no correlation looks like as well. Now, a very important topic on GCSE Higher is histograms. So with the vertical axis, you'll have frequency density. So frequency density goes up the vertical axis, and what you're looking at will go across the horizontal axis. And you'll have a table such as this, and you might be asked to draw a histogram for it. And to draw a histogram, we're going to need to know that frequency density is equal to the frequency divided by the class width. So for each of these categories, we would take the frequency, which is 10, and divide it by how wide the class is. So in this case, this class is 2 wide. From 0 to 2 is 2 wide. So we do 10 divided by 2, and that's equal to 5. Next, that's frequency density. Next, our frequency is 13. The class width is 2. 13 divided by 2 is equal to 6.5. Next, we've got 18 divided by 2. The class width is 2. That's equal to 9. We've got 16 now. This time the class width is 4. It's 4 wide. 16 divided by 4 is 4, and so on. So you then get the frequency densities, and then you draw a bar between 0 and 2 seconds with a frequency density of 5. So you go up to 5, and you draw a bar to 2, and then come down. And then you draw a histogram, and it would look something like that. So it's very important to know for histograms, frequency density is equal to the frequency divided by the class width. Sometimes you might be given a histogram drawn for you and you might need to find some of the frequencies. So frequency is equal to frequency density times class width. So for instance, this bar here, the class width is equal to 20. It's 20 wide. The frequency density is equal to 2.4 because that's 2.4. And 2.4 multiplied by 20 would be equal to 48. So the frequency there would be 48 and so on. So frequency is equal to frequency density times class width. Now also with histograms, as well as drawing them and then answer some straightforward questions on them, you might get some slightly more complicated questions with histograms. So for instance, this one here where there's no frequency density labeled for you. If you were given one of the frequencies for one of the categories, you could then work out what the frequency density would be for that bar, and then you could work out the frequency densities for the others. Or it can also be useful to use the fact that the area is proportional to the frequency. So you could work out how many little squares each person's worth, and then you can answer questions like this as well. So with histograms, I'd highly recommend these videos and also trying to practice questions and making sure you're confident with these slightly more tricky questions whenever you're dealing with histograms. Okay, let's have a look at our next topic, which is cumulative frequency. So cumulative frequency means running total, and you may be given a frequency table such as this, a group frequency table like this, and be asked to complete a cumulative frequency table. And then you just find the running total. So between 0 and 5, that would be 3. Between 0 and 10, well, you do 3 plus 10, that's 13. So we just add on the 10 to the 3 to get 13. The next one, between 0 and 15, well, you can now just need to add on 21. 13 plus 21 is 34. You could add these and get 34, or I've just added on the 21 to what we had before. Now another 4, that's going to be 38, and another 2, that's going to be 40. So we've completed our cumulative frequency tables. That's how you complete a cumulative frequency table. You find the running totals, you add up those frequencies. Now let's have a look at how to draw cumulative frequency. Okay, so we've got our cumulative frequency table, and we've got our set of axes, and we've got cumulative frequency going up vertically. So you plot each of these cumulative frequencies at the end of each category, and that's very important. So we're going to go 5 across, 3 up. So 5 across, 3 up. Now it's important to know the scale too. 5 divided by 10 is equal to 0.5. So 3 up is going to be there. And then we're going to go 10 across 13 up, 15 across 34 up, 20 across 38 up, and 25 across 40 up. Okay, so we plotted the points at the end of each category. Now we're just going to draw a nice smooth curve. So we just start, and in terms of where to start, I tend to look at the beginning of the first category, which is 0. If it began at 10 or another number here, I would start at that number. So this is 0, so I'm going to start at 0 and then just do a nice smooth curve up. And that's it. That's my cumulative frequency curve. So that's how you complete a cumulative frequency table and how to plot and draw cumulative frequency curves. Now in terms of answering questions on them, sometimes you might be given a cumulative frequency curve drawn for you, or you might have drawn your own one, and then you're asked to work out things such as the median, the lower quartile, the upper quartile, the interquartile range, and so on. So to find the median, you find the total frequency. So in this case, the highest cumulative frequency is 600, so there's 600 people here. So to find the median, we half that, and it's an estimate anyway, so we just half that. 600 divided by 2 is equal to 300. So we want the 300 value. So we then get our ruler and pencil and we go from 300 across, and down, and you just read off that value, and that's equal to £6.50. So just to recap that, you look at the total frequency, which is 600. If you want to find an estimate for the median, you half that total frequency, which is in this case 300. So you go halfway across and then down, and then you read off what value that is, and that's £6.50. So the median is £6.50. The lower quartile, well, a lower quartile is a quarter of the way through the data. So you get 600, you divide it by 4, that's 150. So we go 150 across and down, and that'd be equal to £5. The upper quartile, well, you get 3/4 of the total frequency. So 3/4 of 600 is 450. So you go 450 across and down, and that's equal to £8. And then in terms of the interquartile range, that's the difference between the upper quartile and the lower quartile. So we just do 8 take away 5 is equal to £3. So if you want to find the interquartile range, you find the upper quartile, you find the lower quartile, and you take them away. And that's how you find an estimate for the median, an estimate for the lower quartile, an estimate for the upper quartile, and an estimate for the interquartile range using your cumulative frequency curve. Now, sometimes you might be asked questions, for instance, how many people earned less than £4 pocket money? So you go up from £4 across and see how many people got below £4. You might be asked questions like estimate how many people got over £10. So you go to £10 pocket money across, and then you see how many then go above £10, and then you can work out that and so on. So that's how you use your cumulative frequency curve. Okay, next topic is box plots. So sometimes you might be asked to plot box plots or draw box plots, and then you draw 5 lines, one for the lowest value, one for the lower quartile, one for the median, one for the upper quartile, and one for the highest value. And you do a box around the lower quartile, median, and upper quartile, like so, and then you just connect that box up to the lowest value and the highest value, and that's how you draw a box plot. So you need to plot these 5 lines, the line for the lowest value, the lower quartile, the median, the upper quartile, and the highest value. And it's important you know how to compare those box plots and things like that. And if you look at video 149, there's questions there on comparing box plots. Okay, let's look at our next topic, quartiles. So you might be asked to find quartiles. So if you've got a list of numbers such as this, if you were asked to find the median, so as you can see, the median here would be 8, it's the middle value. If we wanted to find the lower quartile, what we do is we consider the bottom half of the data, and then you find the middle of that, which would be 5. And if you want to find the upper quartile, you consider the top half of the data, and then you find the middle of that, and that'd be your upper quartile. And also just remember, if you're asked to find something such as interquartile range, that's the upper quartile, take away the lower quartile. And that's it. So that's how you look at quartile questions. Okay, our next topic is the estimated mean. So sometimes you might be given a group frequency table like this and be asked to find an estimate for the mean. And that's quite nice actually, because we don't know the actual values, but we can choose the midpoints and use those to find an estimate. So we can add on 2 columns, the midpoints. So a midpoint of 0 to 10 would be 5 years. A midpoint of 10 to 20 would be 15, 25, and 35, finding the midpoints of those. So there are midpoints. And remember, for the mean, we would want to add up all our values and divide by the number of values. So what we're going to do is we're going to multiply the frequencies by the midpoints to find our estimate for the grand totals for each of the categories, to find our fx column. So we just multiply the midpoints by the frequency, so 45, 195, and so on. We then add up the fx column to get our estimate for the grand total, and then we add up our frequency to find out how many people there were. That might be given to you in the question sometimes, so you do 9 plus 13 plus 16 plus 2, and that's equal to 40, and then you divide the total fx by 40, and then that'll be your estimated mean. So you just get the midpoints, you then times those by the frequencies to find the fx column, add them all up to get the estimate for the grand total, and then divide that by the total frequency, and that's the estimated mean. Stem and leaf diagrams. So in terms of stem and leaf diagrams, make sure you know how to draw your stem and leaf diagrams. So you're going to be doing them in order. So here we've got 31, 39, 40, 43, 46, 51, 57, and so on. Make sure if you're drawing a stem and leaf diagram, you've also got your key. So 3/1 means 31 minutes in this case. So make sure you know how to draw a stem and leaf diagram. Make sure it's in order. Sometimes it's useful to do an unordered one first of all, and then put it in order and get your stem and leaf diagram. And make sure also whenever you're drawing a stem and leaf diagram that you don't miss any one of the values. So in this case, I'd count them and check there's 1, 2, 3, 4, 5, 6, and so on. I'd count how many I've got and make sure that matches what I was given in the question. With stem and leaf diagrams, you may also be given questions like find the range. So in that case, I would do 75, take away 31 to find the range. So that's how I'd find the range in this case. I would do the biggest value, take away the smallest value. If I was asked to find the mode, the most common one, I would look here and I've got 57 and 57. So the mode would be 57. If I was asked to find the median, the middle value, I'd cross off the smallest, cross off the biggest, cross off the next smallest, cross off the next biggest, and I'd carry on until I would find that median, and then the one in the middle would then be the median. So 57 is also the median in this case. Also, you might be given questions, for instance, what fraction of students took less than 40 minutes. So you then say, well, 2 students took less than 40 minutes. This one took 31 minutes and this one took 39 minutes. I'd find out how many students there are altogether and then write that as a fraction and things like that. So make sure you're ready for that whenever you're dealing with stem and leaf diagrams. Okay, next topic is frequency polygons. So if you encounter frequency polygons on your GCSE maths, you might be asked to draw a frequency polygon. You might be asked to answer questions involving them. In terms of drawing them, if you've got
a group frequency table like this, make sure you plot the frequencies in the midpoint of each of the categories. So here you'd go 10 across, 5 up, and then 30 across, 11 up, 50 across, 20 up, 70 across, 15 up, 90 across, 9 up. And then after you plot the mode, it looks something like that. And just make sure that whenever you draw your frequency polygon, you never join up the first one to the last one. You just do the first to second, second to third, and so on. So that's how you draw a frequency polygon. Also, make sure you know what the scale is. Very important. For instance, here, whenever we were plotting our frequency of 11, that we knew that each one of these little squares was 0.5. So it was going 0.51 and so on. And that's it. So make sure whenever you're drawing a frequency polygon, you're plotting the frequencies in the midpoint of the categories, if it's group data. If it's not group data, then that's quite straightforward. The combined mean. So here we've got 20 students in class A, 10 students in class B. The mean for class A is 60, and the mean for class B is equal to 40. And we're asked to work out the mean test score for all 30 students. So whenever you're dealing with questions like this, it can be quite useful to know that if you take the mean and multiply it by the number of people, that'll tell you the grand total. Because remember, you would have added them all up and divided by 20 to get a mean of 60. So if we take 60 and multiply that by 20, that's equal to 1,200. So that's the total number of marks scored for class A. And then in terms of class B, there's 10 students in class B. Their mean's equal to 40. So if we take the 40 and multiply that by 10, that's equal to 400. So there's 400 marks altogether in class B. So it's quite useful to know that if you've got the mean and you multiply by the number of people or the number of items, that'll tell you the total. And then you just add these together to get 1,600 and then just divide it by 30, and that'll give you the combined mean. Okay, now sometimes you're asked to find those averages for tables. So for instance, if you're asked to find the mode or the modal class from a frequency table, you look for which one's got the highest frequency. So here we can see there's 16 in between 20 and 30. So the modal class would be that class. So you just write that down. That's the modal class because it happens the most. If for instance, it was the ages of people and then you had one with the highest frequency, whichever age has the highest frequency, that would be the mode and so on. So the mode is just the one with the highest frequency whenever you're dealing with frequency tables or group frequency tables. Okay, next, the median from a frequency table. So if you've got a frequency table like this and you want to find the median, one approach is to list them all out if you really wanted to and you've got time. So here you could say, well, 2 people are 18 years old. Then you could say there's 3 people that are 19 years old and so on. And you can list them all out that way and find, write them all down and then find the median, cross them all off and find the middle one if you wanted to. Another approach, and probably the approach that I would use is I would use this n plus 1 divided by 2. If I take the total number of people and add 1 and divide it by 2, that'll tell me the position of the median. So in this case, if we add these numbers together, the frequencies, there's 19 people altogether. So if I want to find the position of the median, so if you line them all up in order and you want to find where the median is, I'll do 19 plus 1, that's equal to 20, divided by 2 is equal to 10. So the 10th person is the median. So the 10th person is not on there. So that's 5 people altogether. 10th person's not on there. The next 13 people, yes, the 10th person will be in there. So that means the median in this case is equal to 20. I said you could list them all out, but if the frequencies are quite large, then that's quite time consuming. So n plus 1 divided by 2 helps you find the position of the median. And if you're given a group frequency table, so if the ages were 0 to 10 and 10 to 20 and 20 to 30, you might be asked which class interval the median lies in. And then depending on the frequencies, and it's an estimate anyway, some people use n plus 1 over 2 and some people just use n over 2 in that situation. Okay, next. Sometimes whenever you're dealing with probability, you might be asked to find the probability of something not happening. So if the probability of Hannah winning a competition is 0.28, you might be asked to find the probability that she doesn't win a competition. And to find the probability of something not happening, you take the probability of it happening away from 1. So you do the 1, take away the probability of it happening. So for instance, if I wanted the probability of Hannah not winning the competition, I would just do 1, take away 0.28, which would be equal to 0.72. The probability of her not winning would be 0.72. Okay, also with probability, sometimes we'll probably get asked to find how many times you'd expect something to happen. So if you want to find out how many times you'd expect something to happen, you take the number of trials. So here a factory makes 6,000 plates and the probability of one's faulty is 0.0035. So if you're asked to find how many faulty plates you'd expect in a day, you would take the 6,000 plates that are made, that's the number of trials, and you multiply by the probability of it happening, which is, in terms of this case, the probability of it being faulty, which is 0.0035. And when you multiply those together, that'll tell me how many times you'd expect something to happen. In this case, that'll be 21, so you'd expect 21 faulty plates. You may also encounter the term relative frequency, and the relative frequency is the number of successes over the number of trials. So if, for instance, we rolled a dice 100 times and we get 17 sixes, the relative frequency of a 6 would be 17 out of 100. 17 sixes out of the 100 times we rolled the dice. So relative frequency is the number of successes over the number of trials. Okay, now sometimes you may encounter independent events. So they're events that whenever they happen, they don't affect the outcome of the other one. So for instance, if a spinner spun twice, such as this spinner, if it spun twice, what it lands on the first time won't affect what it lands on the second time. And here we've got some probability. So the probability for white is 0.1, the probability if it landed on red is 0.4, the probability if it landed on black is 0.3, and the probability it lands on brown is 0.2. And if we were asked to find the probability that this spinner lands on red twice, that's the probability of a red and a red, so red and red. So what we do is we take the probability for red, which is 0.4, and you multiply that by the probability for landing on red again, which is 0.4. And 0.4 times 0.4 would be 0.16. So the probability if the spinner landed on red twice would be 0.16. And you just take the probability for landing on red and multiply by the probability if it landed on red. If we're asked what's the probability if it landing on red 3 times, you do 0.4 times 0.4 times 0.4. If you're asked to find the probability if it lands on white twice, you do 0.1 times 0.1. If you're asked to find the probability if it lands on white and then red, you do 0.1 times 0.4 and so on. And that's it. If you're asked to find what's the probability if it lands on the same color, if you spin it twice and lands on the same color, you would find the probability for white and a white, a red and a red, a black and a black, and a brown and a brown, then add them all together. And if the question asks you to find what's the probability if it spun twice and it lands in different colors, you'd find the probability if it lands on the same color, like we just talked about, and take that away from 1. Another topic you may encounter is samples. So remember, samples are just a selection of the whole population. So it's important that a sample is representative. So for instance, if I wanted to find out if students like school, I wouldn't necessarily just ask year 7 students in my class, because obviously they're going to love school. So make sure your sample is representative. So it would take a selection of students across year groups, maybe boys and girls in all different year groups and so on. Also, you might be asked to answer questions like this, where there's 480 students at a school. A teacher has surveyed 50 students, asked them which color of blazer they would like, a new blazer. So 20 of the 50 want black, 15 of the 50 would like navy, 9 of the sample of 50 would like green, and 6 of the sample of 50 would like maroon. And if the teacher wanted to estimate how many of the 480 students would like a navy blazer, well, 15 50ths of her sample, so you'd cancel that down as a fraction, and then that'll tell you what fraction of the students wanted a navy blazer, and then you could just work out that fraction of 480, and that's it. And if you're studying at Excel, you may encounter capture recapture, and this is the formula for capture recapture. Now I'll talk about it in another way in a second, but this is the formula. M over N equals R over T, which is the total marked over the total population is equal to the number recaptured over the total capture on the second visit. So that's the formula. However, whenever I'm tackling capture recapture questions, normally what I do is I just think of the information I've been given. So for instance, imagine I've gone into a greenhouse and I found 500 wood lice and I've marked them all with a little mark of Tipp-Ex. Then I would have caught 500 on my first visit out of the total population. Then if I went back the next day and I found 100 wood lice and 17 of them were marked with Tipp-Ex, then that would be 17 over 100. And then we could just solve this and find out what N is, our total population. So it's the number you capture in your first visit out of the total population is equal to the number that you recapture, so the number that are marked, over the number you capture in your second visit. And that's it. Tree diagrams. You may encounter tree diagrams on your GCSE Maths exam. At some point you know how to complete those tree diagrams and how to answer questions on them. So here we've got a tree diagram with John and Dan and hitting and missing targets. So the probability of John hitting is 0.6, so the probability of him missing would be 0.4. In terms of Dan hitting is 0.7, so him missing would be 0.3, hitting would be 0.7 and missing would be 0.3. So once you've completed your tree diagram, you may be asked to answer questions involving it. So you might be asked, what's the probability that both of them hit the target? So to find the probability of a hit and a hit and a hit, you multiply the two probabilities along the branches. So we would do 0.6 times 0.7, which would be equal to 0.42. So whenever you're dealing with tree diagrams, you multiply the probabilities on the branches. So a hit and a miss would be 0.6 times 0.3. A miss and a hit would be 0.4 times 0.7, and a miss and a miss would be 0.4 times 0.3, and that's how you'd find the probabilities. And then you might encounter questions like, what's the probability that both men hit the target? That'd be 0.42, or both men missing the target, 0.12. What's the probability that only one man hits the target? And then that'd be either that option or that option, so you then add those together, because only one man hitting the target, it could be John hits it and Dan misses it, or John misses it and Dan hits it, so you'd add those together to get 0.46. Or it could be at least one man hitting the target, and then that would be that option, and that option. Then you'd add those together if it's at least one man hitting the target, because either one could hit it or both could hit it, and so on. So make sure you know how to answer those tree diagram questions. So we've looked at independent events and tree diagrams. You may also encounter in GCSE higher conditional probability, and that's where the probabilities change. So for instance, here we've got a bag that contains 2 apples, so an apple, and 3 bananas, banana, banana, banana. And Olivia picks 2 items out of the bag at random without replacement. She's going to take out a piece of fruit and then another piece of fruit. And the question says, what's the probability of her picking 2 apples? So we want the probability of an apple and another apple. So in terms of the first one being an apple, well, in the bag there's 5 pieces of fruit. 2 of them are apples, so probably the first one being an apple would be 2/5. And then once that one's come out of the bag, now there's only 4 pieces of fruit in the bag, and one of them's an apple. So probably the second one being an apple will be 1/4, so 1/4. And then if we want the probability of an apple and an apple, we just times these together. 2 times 1 is equal to 2, and 5 times 4 is equal to 20, and that cancels down to 1/10. So the probability of her picking 2 apples would be 1/10. So whenever you're dealing with conditional probability, the probability will change depending on what happens, and that's it. Okay, so that's conditional probability. Okay, let's have a look at our next topic. So our next topic is Venn diagrams. So it's important that you know how to complete Venn diagrams. So you may be given information in a wordy question like this, where you've got people liking drink A, B, and C. And it says 90 people were asked if they liked 3 drinks. So there's 90 people altogether. 11 people liked all 3 drinks, so 11 people liked all 3, and so on. So you need to be able to complete Venn diagrams based on information like this. And if you look at the practice questions, they'll be useful for you as well. And then it's also useful to know the notation. So here's some notation that you may encounter whenever you're dealing with Venn diagrams. So we know that A would be A and B would be B. A dash means not A, or the complement of A, so it means outside of A. B dash means not B, or the complement of B, so that means outside of B. A union B means A or B, so it's anything in A or B, so shown in that yellow region there. And A intersect B, that little N shaped and intersects, that means intersect, that's A and B, so that means anything that's in A and B. So it's important to know your notation whenever you're dealing with Venn diagrams. And that's it. So we've gone through frequency trees. So it's important you know how to complete those frequency trees and answer questions based on them. Two-way tables, so how to answer questions where the two-way table's been given to you, or where you might have to make your own based on some wordy information. Pie charts, how to draw pie charts and how to answer questions if you've been given pie charts. Scatter graphs, so knowing how to plot the points, how to draw the line of best fit, how to use your line of best fit, when it's not necessarily the best idea to use a line of best fit, so whenever it's beyond the range of the data. Also your types of correlation, your positive correlation, your negative correlation, and your no correlation. Histograms, so frequency density is frequency divided by Collatz width. Frequency density goes up the vertical axis. Also that sometimes it might be useful to know that frequency is equal to frequency density times Collatz width, and also how to answer some trickier histogram questions. So questions that may involve you considering the number of squares and how many people that represents and things like that. Cumulative frequency, that means run on total. So how to complete your cumulative frequency tables and then draw your cumulative frequency curves, and how to use those cumulative frequency curves to find estimates for the median. So go halfway across and down. The lower quartile, 1/4 of the way through the data and down. The upper quartile, 3/4 of the way through the data and down. And also how to find the interquartile range. So you do the upper quartile, take away the lower quartile. Box plot, so there's 5 lines you draw, the lowest, the lower quartile, the median, the upper quartile, and the highest value. So and then you do a box around the lower quartile, median, and the upper quartile, so that middle 50% of the data. And then also you join that up to the lowest value and the highest value. Quartiles, so how to find quartiles from a list. How to work out an estimate for the mean for group frequency data. So find your midpoints, multiply those by the frequency to find your FX column. Add up your FX column to find your estimate for the grand total, and divide that by how many people or how many values there are, and then that'll tell you your estimate of mean. Stem and leaf, how to draw stem and leaf diagrams, knowing what the key is, how to find the range, the median, the mode, and so on from stem and leaf diagrams. Frequency polygons, so remember that if it's a group frequency, to plot them in the midpoint of each category and to join each of the consecutive points up, but never the first and the last one. The combined mean, it can be useful to know to find the grand total. You multiply the mean by how many values there are, and then that'll tell you the grand total, and then you can use that for the total for each group, to then add them up and divide by the total frequency to find the combined mean. How to find the median from a frequency tables. Modal class, so the one with the highest frequency. Probability, so being able to answer probability questions. So it might be, for instance, you've got a table, you might need to find missing probabilities in the table, or it might be the fact that you want to find out how many times you expect something to happen, so multiply the probability by the number of trials. Or it may be independent events. So remember, they're events that don't impact each other, don't affect each other. So you just multiply the probabilities together to find out the probability, for instance, of a red and a red. You just multiply the probability for red by the probability for red. Relative frequency, so the number of successes over the number of trials. Sample, so knowing when a sample is representative or not representative of a population. And also if you do an LXL, knowing your capture, recapture. Tree diagrams, so being able to complete tree diagrams, and then multiplying along the branches to find the probabilities, and then being able to pick which of the outcomes would then match what you've been asked for. Conditional probability, so that's where the probabilities change. So for instance, if you're taking 2 pieces of fruit out of a bag or something like that, so you need to change the probabilities as you're doing the question. And Venn diagrams, knowing how to complete Venn diagrams, and also knowing the Venn diagram notation. So there's some important statistic topics for you, and I hope this recap's been useful.
And that's it. So in this video, we'll focus on the statistics topics. I really hope you find this video useful. Remember to check back tomorrow, because tomorrow we're going to go through the algebra topics, and the day after the geometry and the shape, space, and measure topics. So see you then. Cheers. Bye.